you have 5 more minutes. Thank you. You already got yours, right? Thank you. And then, I really just gonna email, where's your t-shirt, so you can come back in and finish it, okay? Have I not gotten anybody's understanding check? Chicago. Anything can you hand me Chicago's? And can you hand me Caleb's, and Caleb I'll email First Sergeant Davis. Thank you. Alright. Please make sure you get logged into Desmos. The code is up on the board. Then type in the wrong password. Click on forgot the password. Oh, you have caps lock on, that's why. So everything that you typed with a letter was the opposite of this. Basically, try doing it now. Notice you want caps lock off. Try it now. I'm just telling you, it was on when I just looked at it. Alright. Quick show of hands if you are not in Desmos yet. Okay, hurry up, let's get there. Only a handful of us are there. While they're still logging in then, let's look at our agenda and objectives. I will say I forgot to put one thing on here. So we have the forms of quadratic equations, right? We're looking at those features of quadratic equations. What are the features that we should be thinking about? Right? We need to identify the key features or characteristics. The vertex, what else? Axis of symmetry. Say again. So the parabola is, remember, the shape of that quadratic function, right? But look at your graphic organizer that we were filling out yesterday. We got vertex, axis of symmetry, concavity, x-intercepts, y-intercepts. I think that's it, isn't it? Yeah, that's it. All right. So remember, we need to identify the key features, and I want you to notice, and I want you to pay attention to this. Not just the key features, but the key features revealed in each form of a quadratic equation. I need you to hear me very clearly on this. When we looked at the vertex form yesterday, what were the only features? Come on, what were the features we saw in vertex form? I mean, they were there, but did we fill out information about the x and y intercepts? Concavity, axis of symmetry, and vertex, right? Do not forget, that was the only things we saw directly in the vertex form. So if I give you vertex form, am I going to ask you to give me the x-intercepts right away? No, Mr. Kenny, because we didn't talk about it. Yeah, great job, guys, right? Like, I want you to pay attention. We're only going to look at those features. Remember, we said yesterday, if we have this vertex form, which I will point this out, we are going to get more practice on this Thursday and Friday. Ms. Courtney is developing a great lesson, or has already developed it, and she's going to present that Thursday and Friday. But here's our vertex form. You got to be able to recognize that right away, right? And so Anthony was asking about one of the equations on the understanding check if it was a vertex form. Is this the form it was in? No, right? So it wasn't vertex form, but that is something we want to pay attention to. And so remember, we summarized yesterday that the vertex is h comma k. We summarized that the axis of symmetry is what?
X value of the vertex.
X equals what?
H.
H, the x value of the vertex, right? And I thought that's what you said. And then concavity,
With a positive.
if A is greater than 0, it was what?
Positive.
Well, A being greater than 0 is positive, but what does that mean? What does it tell us about concavity?
It's up concavity.
Concave, up. And if A was less than 0 or a negative,
Concave down.
concave down, right? Those are summary things, and we're going to pick back up with that today. And then we're going to try to use the features of the quadratic function in any representation to write an equation. All right, so we should be in Desmos. We should have these details figured out or filled out. So this is where we are picking up. I need y'all to hear me very clearly on this. You do not need every single slide filled out. You can come back in later and add more if you want to. But what we need to be working on right now is this, working within our small groups. I'm going to give you about 5 minutes, maybe 8, to fill out this table. This is on slide 8. Yes, sir.
My stuff isn't working.
I'll come and check in a second. To the computer? Oh, just to Desmos? Did you use a different password than what TCSS password was? But you logged into the computer, right?
Exactly.
Did you check one thing, because Omar, were you able to get it to work after you turned caps lock off?
No,
You still had to reset? Just go to reset password, and then go to Office 365, and it'll send you a link to reset your password. That's the best way to do that. Okay, so I want you to notice, each of these equations is in what form?
Vertex.
Vertex form. So you need to use this information to identify the vertex. And when they say line of symmetry, a friend of mine developed this originally. I forgot to change it. He uses the term line of symmetry. I use still the term axis of symmetry. Same thing. And then concavity. We're working on that within your small groups. I'm saying 7 minutes at this point. Fill this table out as much as possible. We're going to come back and have a whole class discussion about it. But if you finish the table early, what are you going to do? Keep going. I want you to notice we have a new form of a quadratic equation. Does anyone know which form this is? That's standard form. And we're not just like making this up. What page are you looking at in the graphic organizers? 73. If you look at 73, it has that same exact form up there, and we're going to follow the directions just like we did with vertex form. Any questions? Alright, let's start filling out the table.
This is the vertex formula. That was the same one.
Huh?
That was the same one from the
No, it wasn't. The one was like this. Because it was AX, right?
it was this was KX. So what kind of function is it?
It's the standard form of a what? What type of functions are we studying?
Vertex.
No, standard form of a...
Lemon?
Did any of these look like a line?
Quadratic?
That's a parabola, right? So it's what?
And that's a parabola?
Well, the shape of the graph is a parabola, so it's what type of function?
Vertex?
What type of function has a vertex? There's linear, exponential, and quadratic.
Quadratic.
Thank you.
Okay.
Okay? We're going to keep exploring it, but keep that in mind. All right. Sorry, continue working. We've got about 5 or 6 minutes. You're supposed to be working within your small groups to complete this table. Oh, thank you.
I'm just wondering.
And we're just continuing on experience.
Because you did it before with your friend.
That if it's plus or if it's plus anything, yeah, it's subtracted by
So what are we thinking about for the vertex of that first function there?
He explained that yesterday.
Do we have our graphic organizer out with notes about the vertex and the line of symmetry and the concavity? So remember, this is the one from the book, right? Do you have your book with you, or did you just tear it out? Here it is. So, how do we find the vertex when we have vertex form?
There you go. Okay. You're looking at.
Yeah, how do we find the vertex? You have the notes there, I see them. Look at the very bottom. Vertex is H comma K. So look at your equation, right? Match it with this, figure out what H and K are. Come on, we gotta move more quickly. Yes, ma'am.
I need to see if I'm doing this.
Well, so notice how you say x equals 3, but okay, first off, vertex would be x comma y. What did you say notice? Whatever H comma K is. But it's not, what is it? You should say the H comma K is the vertex. Right? So H is here. What's the H value in this first equation? No, because look, it's only x minus h squared. So what's the h value? Why are you squaring it? Look, that is h. Just that number. Okay. We'll go over it and you might need to update it some. If you think that's what h is. But no, I'm talking about the vertex. You said that you think the x value of the vertex is -3, right? So then what would the y value of the vertex be?
Sorry,
2?
Okay, Ms. Gordon.
What did we say is the y value of the
He
vertex?
said that, or if it's like this.
K. Where do you see the k?
The original part.
Huh? Right?
The office, this is the 5-way on my school. I'm not using my school, and I decided to try another way. And I was thinking if I could get my phone so I can sign in.
Are you sure you used your TC?
The general equation.
So, I'm gonna show you how to
So you're talking about, you think it's -1 and -1?
actually, I know,
If that's what you think it is, convince me it's -1.
Because that,
So how did we write it yesterday for the axis? It said x equals.
that's why I got that.
So, you know, she would
Vertex, it's gonna say vertex, and then it say H and K. I got
This is the H.
I got H from right here, K, whatever the last.
Well, we'll talk about it. So remember, so let's see here, it's written x equals.
Less than, if it's greater than 0, less than 0, go there. You just put up or down.
Quick question, why are you doing 3 comma 4 about the line?
because of that, negative 5.
Is that what you have written down there?
Symmetry to the left, right?
What did you write down for axis of symmetry?
And then, the first number gonna be the same as the line of symmetry.
I think y'all flipped some of these. Okay, about to go over it, so.
Remember so the vertex is a point on the graph.
They gotta put a comma.
And what else?
Whatever.
Thank you. All right, so let's go over these so that we can move on to the next section, but I want us to look at a couple details. Does anyone want to push back on the concavity at all? Or do we agree up, down, down, up?
We agree.
Yeah, we've grown that
I
right.
can't see those.
Anybody want to ask a question or push back then?
I got a question.
Well, we're going to do concavity, then we'll look at the other two. Sound good? Okay, so let me ask you this, Eli. Why do we say that the concavity is up for this first function here?
I'll put down.
You put down, so you should have said, hey, I want to push back on it. I didn't know that you said down.
I was doing that. Okay.
Okay, I need y'all's attention up here. Remember, guys, it's the thinking side of things, looking at other people's responses and pushing back and asking questions that's going to help you grow and learn. So we should be stopping with the computer right now and focusing on the whole class discussion. Okay, so why do you think down, Eli?
Because H is -3.
Okay, so H is a -3. Does anyone want to push back on that idea? And explain maybe why they were thinking that it should be up? Okay, Anthony?
Because the A is positive. If the A is positive, then it should go up.
Okay, so where do you see A?
2 is the A.
Does anyone have a question about that being A?
Because it's the A in the formula.
So remember, A times X minus H squared plus K. So Eli, I got a question for you. Is it H or is it A that determines the concavity?
A.
A?
I think, yeah.
Yeah? Is that what we wrote over there? So, is A positive? So it should be concave up. Dawson, so why is this second one here down?
Negative.
It's? What do you mean by it's?
The A is negative.
Okay, so the A, which is what value?
-1/2.
Ah, the A is -1/2, so it's concave
Now.
down. Make sense? Make sure you have the concavity there. Okay, so let's look at the line of symmetry. Anybody want to push back on these lines of symmetry or ask a question?
I do.
What you got, Kyle?
How did you get -5? Why wouldn't it be +5?
Ooh, that's a good question.
That's
So, hold on, hold on,
Dang.
No, I don't want you to.
hold on. Now,
No.
I want someone else to get involved, and if no one feels like they can answer, let Anthony jump in there. But Kyle, what you got?
You know Kyle forget.
You know this right.
But here's the thing, I want him to justify, I want to get everyone as involved as possible. So, what are you thinking?
Isn't it like, you said somebody yesterday,
I did.
even if it's like +5, but in reality it's minus -5.
Oh, where are you getting this idea of minus a -5?
Isn't that the formula?
What about the formula? Let's look at that. It's x minus h. So in order for it to become a +5, when we were subtracting, we had to subtract what kind of number? A negative. So h is actually a -5.
And same thing with 8.
I thought it be like I thought it was because like your first number is a negative and you just positive.
Which number, like this one here? Is that
No,
what you're talking
like whatever your number, whatever, like if you got a negative, I thought you just put it with your line of symmetry.
Well, and so notice the format, right? Because it's x minus h, when I look right here at x minus 3, the x minus stays the same, so what's the value of h? Just a +3, right? So you have to go back to this form, x minus h. So when it's x plus 5, it was x minus a -5, okay? When it's x plus 1, what is the value of h there?
-1.
-1. And so I might write this note down to myself either under axis of symmetry or vertex, because I did mention this. Because we're subtracting, h is the opposite. Meaning that the sign, what?
Flip.
Changes, right? Positive to negative. So if it's x minus 3, h is actually a +3. If it's x plus 5, h is actually a
Negative.
-5.
I
And it's
just think
going
the
back to the x minus, huh?
I just think the opposite.
And that's what I just said, right?
Oh,
H is the opposite of that sign.
oh, my bad.
I might make that note to myself under axis of symmetry or vertex, noting that, hey, it's the opposite of whatever that sign is there. Omar, you look like you got a question.
Well, I see what you're saying when you like flip it,
Yeah?
but like you see.
Be careful. What do you mean by flip it?
It's the opposite.
It's the opposite, right? That, remember, the mathematical word for changing the sign is opposite. So we do want to use the word opposite in this case. Go ahead.
Well, for like the other one, like you see, for the vertex, it's like -8, and then you got the line of symmetry, like +8.
Oh, so if this is an 8, this -8 should maybe be a +8? What do y'all think about that? Yes? Good catch. It should be an 8. And I do want to point out, they start out right up here where they're writing it as a what?
Plot,
A point.
point,
And so it needs to be 8, comma,
12.
12.
I wonder who did that wrong.
Right? And again, the opposite, so -1. And I want to point out, I talked about the H is the opposite. Is K the opposite?
No,
No. K is whatever sign is with it. Okay? Alright, any more questions about that vertex?
no sir, everything straight on.
You think? Anybody want to push back on the axis of symmetry anymore, that we might be missing something? Well, I got the X value, right? That's H.
Axis, yeah, central.
I'm missing something with it though.
You say X equals 8.
X equals H.
So X equals 3.
X equals 3.
Ooh,
X
okay.
equals -5. X equals -1. X equals 8. Remember, an axis of symmetry is a full line, so you need X equals in there.
Okay. Learn something new.
Correct. Because here's the thing. The number 3 is the number 3. You type in X equals 3, what that means is it doesn't matter what the Y value is, the X value is always 3. And so here's a point where the X value is 3, here's a point where the X value is 3, here's a point where the X value is 3, and here, and here, and here. Notice that creates a vertical line.
But we ever
If
had
you
to
don't
solve.
have the X equals, then you don't have a line. And so again, I will point out, how did I write the axis of symmetry? X equals H. You have to have the X equals to have the line of symmetry. What were you gonna say, Anthony?
Oh, it's like we ever had to solve problems like these?
What do you mean, solve?
Like,
break them down.
yeah, break them down.
Yes, that's why we're covering it. Remember, that's actually the second objective, is to identify the features of a quadratic function, right? Based on the, revealed by the equation. Yep. So, Omar, I'm gonna put in the X equals 3, X equals -5. Okay, so we need to move a little bit more quickly now. So I want to point out here, which page should we be looking at on our graphic organizer in the book? 73, because what form do we have? Standard, right? So you need to know when you see f of x equals ax squared plus bx plus c, that you're talking about standard form. Now I'm going to go ahead and tell you right here and right now, we are only going to look at A and C. Those are the only two we're looking at. So, follow the directions on the board, figure out what you think A is doing to the function, and then write about it a little bit, figure out what you think C is doing to the function, write about it a little bit, pay attention to what we're asking you, because that will help you figure out what to write about. Any questions? Let's get to work.
Where's the website going? Is it lights?
No, don't do that. What's the only thing it asks you to adjust?
A and C.
On slide 9 was the only thing it's asking you to adjust. What does it say up here in slide 9? Adjust the value of A. Y'all, please notice what's the only value you're adjusting on slide 9? A, that's it. Pay attention. Also consider and think about what we have looked at in the past. That's how you lose points on active collaboration. Keep going. Keep going. You can go all the way. Keep going.
Look,
What's A doing?
it's the edge.
Think about what have we seen A before?
How is the edge and edge what?
What did we talk about with A in the
That's what I'm
past?
trying to tell her.
Remember, think about the features that we're trying to study.
Not A.
What is A affecting? What did A affect earlier?
Yes, it does.
No, A didn't affect earlier. No.
What?
What did A affect earlier? When we were looking at vertex point.
How does that
And C is the white also.
Are you looking at your notes on vertex form to see where we wrote about A? Oh, A affected the concavity? I never disagreed with you. I asked another question to get us to think. Is A affecting the concavity here? Okay.
But I didn't move.
Go to your next slide and look at
Because
the,
it says 0.4.
oh, look at the questions. When the value of A is positive versus the value of A is negative, right?
Okay, look.
We want to think about those things. It never asks you to adjust B,
Hold on, look.
only adjust the A. Gotta follow those directions.
4.5. 4.5. 4.5.
If you are a little stuck on slide 9, I might suggest you look at slide 10.
See the white inside.
Look at slide 10 to help you think about what we should consider for A. Remember, don't write yet, just type. Okay, so be careful. That language can get you messed up. A is not the concavity, because A is a nothing. But what does A affect? Okay. Notice I asked when the value of A is positive. What do we know about the parabola?
When the A is positive?
Yeah. So adjust that value of A. See, you have a positive A right now. When the A is positive, how would you talk about that parabola? It's what? Okay, and the term is concave up. Versus when A is negative, what do we see? Check it, show it. Right? So adjust your A. Right? Nope, A needs to be negative now. Keep going. Not negative. Keep going. Can't see the whole thing. Okay. When A is negative, that parabola is what?
What you got?
Okay. So that's what we should be writing about. Move on to the next slide after that. Eli, what are you doing? Get your head up and work. You would leave an Indian out to dry.
Positive versus the value of A.
I will say this, just focus on question 1 for now. Hey guys, on slide 10, just focus on the first question. Don't stress about the second one. What Miss Courtney's going to cover next unit is going to cover that idea.
And the value of A is positive.
We think they don't. What? Wow.
I think we're supposed to be respectful to everybody now. I would not zoom out like that. But so what do you think? And Anthony started this idea off when A is positive. What?
It's concave up.
What's it?
The parabola.
Do you agree with that? Okay. What about when A is negative?
That ain't true. Because it
I
depends.
feel like we moves closer.
So what I will point out and remind you of when we looked at the vertex form, what did we say about A?
Same value.
Oh, so do you think it's the same thing again?
No.
Why not? It's still A, isn't it?
Because it's negative right here, and it's still,
What do you mean?
A is negative?
You have to figure out what C is.
Did you say negative before you said that number?
It affects the ground.
But it's 0.
It's 0.9.
Anything under 0 is.
Under 0. That's not under 0.
Oh.
Under 0 is literally When a negative, when
You
a
can face the
zero.
ground vertically.
Yep. We talked about that a little bit yesterday, but we don't want to look at A is 0.
I think this is one more.
Remember, the question was when A is positive versus negative, right? So write about that. Come on, we got to get moving.
So it goes up and down.
When A is negative,
Oh, what is it, the opposite?
so it's concave, and when A is positive, okay, come on, write that, let's go. Y'all, we should be on slide 11 by now, easily.
Where's the kid?
What is what? What is? C is what? Scratch that. What Y value are you talking about? Yeah, I mean, yeah, that's C, but where do you see that in the parabola? Where do you see C?
Parabola.
What is that called? Are you talking about like that whole line? Are you talking about the point there? Kyle, can you help her develop her language?
What are you trying to say?
What about it?
I think the vertex is up here, isn't it?
Vertex.
Yeah.
I really.
So I think she's talking about this point.
Yeah, I really.
What point is that called?
Or the purple dot.
How did y'all write y'all's
Come on, we're so close. What is that point called? Where we're intersecting the y-axis. Notice how the x value is 0? Come on, what is that point called?
How you spell parabola?
What was the first one you said? Is that called the y-intercept? Where we intersect the y-axis? Oh, there we go. I want to pause and I want you to look at that y-intercept again. Because those might be the right values, but you do not have a y-intercept.
See, it's just a point.
Guys, how do we write a y-intercept?
So on slide 11, we want C.
I never said that. I said you might have the right value, but I asked you, how do we write a y-intercept? Go back to slide 11. How do you know you have a y-intercept? I say what?
I didn't know you irritated.
Come on, 13.
Well, so it's got 0, comma, something, so that y-intercept is a mid-coordinate. Do you have a point for your y-intercept?
What are y'all?
What?
C is
this?
Talking about that point where we intersect the y-axis? Do y'all know what the, so you're noticing, you're thinking that C is that purple point there?
Yeah, I think C is the y-axis.
Okay. What's that purple point called? Oh.
I know this.
So is it the y?
But that purple point is called the what?
Y-intercept.
Y-intercept.
That's what I'm on right now.
Well, I don't
The
know.
C is the,
Have I asked you to look at the, no, I